Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors as velocity. So as per the problem, an airline has an airspeed of 300 kilometers per hour and is heading due west. If it encounters a wind blowing south at 50 kilometers per hour, what is the resultant ground velocity of the plane? So the first step is to draw the vectors for the airplane's velocity and the wind's velocity. So the airplane has an airspeed of 300 kilometers per hour heading west, and west is shown to the left side. So this can be the vector for the airplane's velocity. And the direction is west. Now the wind is blowing south and the speed of the wind is 50 kilometers per hour. So the vector for the wind should be much smaller than the vector for the airplane's velocity. So this is, and the direction is south. Now we have to find the resultant ground velocity of the plane, and that will be the resultant of these two velocities. So to find the resultant, we have to arrange these two vectors in tip to tail format. So we'll start by drawing the vector for the airplane. And then from the tip of this vector, we'll draw the vector for the wind. And these two vectors are perpendicular to each other because west and south directions are perpendicular to each other. So the resultant of these two vectors is the side that represents the hypotenuse in this right angle triangle. So we can label these vectors. So let's assume the vector for the airplane is v1 and the vector for the wind is v2. So we have to find the resultant vector, and that means we have to find its magnitude and direction. So we can find the magnitude by finding the length of the hypotenuse, and for that we can use the Pythagorean theorem. So our equation will be so R represents the hypotenuse, so that's why it is shown on the left side. Now we are given that the speed of the airplane is 300 kilometers per hour, so that's the magnitude of vector v1, and 50 kilometers per hour is the magnitude of vector v2. Now we can do this calculation. So 300 square plus 50 square is equal to 92,500. Now we can apply square root to both sides. So on the left side, the square root and the square cancel each other out. So I got 304.14, and the unit is kilometers per hour. So this is the magnitude of the resultant ground velocity of the plane, and now we can calculate its direction, and for that we need to find this angle theta. So we can use the tan ratio. For tan is opposite over adjacent. So the opposite side length is equal to the magnitude of vector v2. And the adjacent side length is equal to the magnitude of vector v1. Now we can do the inverse of tan. Now we can evaluate it. So I got 9.5 degrees. So the resultant ground velocity of the plane can be written as and the direction is west, 9.5 degrees, south, because the resultant is at an angle of 9.5 degrees from V1, which is directed west, and it's going from V1, the resultant is 9.5 degrees towards south. So that's why the first direction is west and the second direction is south. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.